Alright, Chapter 19, track drainage. Track drainage can be defined in the interception collection of the disposal of the water from the upon and under the track accomplished installing the proper surface and subsurface of the drainage system. Need for proper track drainage. The greatest threat of the railway is most prominent effectively adversely affect the track maintenance and proper drainage. The excessive water affects the stability and embankment, the bearing of the capacity of the soil, resiliency, shear of the grass of the considerably reduced. Railway engineer give the maximum importance. The proper drainage of the track need to be due to its felt to cover the following concerns. Settlement of the embankment. Excessive water may cause the embankment to settle. The unequal settlement may lead to the various across level, the longitudinal level, affecting the safety of riding the quieting track. Reducing the bearing capacity. The bearing capacity of the soil as well. The resistance shear the diminishing due to the excessive water in the soil that turns lead with numerous problems that finally affect the safety and the stability of the track. Failure of the embankment. The percolation of the water embankment increases the weight of the soil with one hand, reduces the bearing capacity and shear of the resistance for the other, making the formation unstable. The common reason for the failure of embankments which occur with the form of the slips. Formation ballast package. Excessive moisture leaves the function for the formation of the constant hammering action of the running train with the cover of the sleeper to move it up and down, the resulting in ballast pocket, the bumping of the sleeper, other such problems, as well as all these factors low poor riding quality. Shrinkage and cracking of the banks of the embankment, the soil cracks and shrinks once again. Excessive water dries up. The problem becomes actuated with the cover of the poor soil. This is in turn leads to many problems such as the low ballast, the cracks, and uneven settlement, which have adverse effects on track maintenance. Adverse effect of the black cotton soil. Certain soil such as black cotton soil, which becomes plastic in the nature of the due to the accumulation of excessive water and the formation strength due to the change of the moisture content and the bearing capacity of the soil greater reduces the excessive water of the problem and imperial safety of the track. Formation of the slush. Slush is formed with a dynamic load with the running train with the force out with the badly clogged with the ballast makes the maintenance of the track very difficulty. 9.2 Source of the percolated water in the track. Water can percolate with the formation of the track throughout any of the following method by gravity and includes the water collected through the drain, moving into the subgrade during the effective gravity movement of the resisted permeable soil. The effect of the wave, the reducing the progress of the water, and the method of following the provision of the drainage at the top of the embankment from the cross the fall side of the drain, lowering the success of the turfing the side slope of the embankment by calipary action. At the time the water rises to subgrade by the calipary action, the calipary rises the water provided with the previous layer of the embankment in which served the calipary break. For adjacent areas, in case the water is somewhere nearby a source of the seepage to the subgrade, whether seepage can be reduced by taking the following steps: diverting the original source of the water, providing effective paved catch water drains, and providing inverted filters on underground drains. By hydroscopic action in the atmosphere, the moisture is present with the atmosphere comparatively very small, very little effective soil moisture can content in the soil. 19.3 Requirements of good track drainage system. The good drainage system should satisfy the following systems. Surface water should not porolate with the track. The basic requirements of the good drainage system surface water with the rain. The adjacent areas should not percolate and seam the formation of the track. Effective side drain should be adequate with the proper slope of the soil to effectively carry all the surface water away. Longitudinal drains to be saucer shaped. Longitudinal drains provided with between the two tracks should be preferably saucer shaped cross section so that they can collect water from both sides. Provision of clearance and inspection of the drainage provided with the drainage should then be such that the inspected clear periodically. Drain top of the below the cess level. Normally the drain top should not be above the cross level of the effective drain of the ballast spread of the non-erosion bank. Flow of the water slope of the cross of the track should be non-erosion of the banks and slope of the banks. Formation to be good. Soil and deal with the formation subgrade should be made of the pervious coarse texture soil. Such soils are permeable to retain less of the calipary water and respond favorably to the source of the drainage system. Proper surface damage drainage arrangements should be made with a good surface drainage and system drain off the water to be retained in the track. This is the most relevant and capable to deviate and defective formations. Proper outfall. Longitudinal drainage should be designed to provide proper outfall where the water can effectively drain off. Special arrangement of waterlogged areas and other difficult situations. A good track drainage should be especially arrangement of the drainage of the waterlogged areas, other perennial problems. 19.4 Practical tips for the good surface drainage. The following measures will ensure the track drainage give it the good to perform the maintenance for the proper cess level. The track maintenance to get the drainage along with the proper cess level to maintain the ballast clean. However, the cutting of the yards whenever the water cannot recede freely and quickly from the track, the well-planed drainage system must be provided. No vegetation. There should be no growth of the vegetation in the track to indicate the closing of the ballast for the lack of the adequate track drainage. The stretch of the track should be overhauled with a deep screen, but the ballast should be cleaned so that the rainwater can easily flow over the track. Aerial below area below the rail of the foot to clear. About 25 to 50 millimeters of the air below the rail should be clear of any ballast earth in the center of the lines for the inside of the outside of the yard. This would enable the good surface flow as well as avoid corrosion and failure to track surface cleaning of the repaired drains. All the drains should be cleaned and repaired as the part of the annual track through thorough packing, not only the running of the line through the lines, but also other running lines in the yard. 19.5 Track drainage system. Mentioned earlier, with each of the good track drainage system should be ensure no water percolates from the track at either subsurface or subsurface level. The arrangement of the drainage subsurface water should be good and effectively required. The track drainage should be handled in two distinctive places. Surface drainage to the surface water due to the rain, so on the show the adjacent area should be drained properly for the design, well planned, effective surface drains. Subsurface drains. In case of the water percolation in the formation due to the bad soil, especially without the reason formation will get adversely affected with has been bearing safety and stability with the track. Complete details of the same are given in Chapter 9. In the following section, surface drainage is dealt with the three different stages of the curve covering the entire length of the track. Drainage of the midsection between the railway stations, drainage of the station yards, and drainage of the station platforms. 19.5. Drainage of midsection between the railway station. The drainage system between the two railway stations consists of the following features. Side drainage. Side drainage should be provided with the track cutting with zero fill locations, cross level and available at the ground level. The typical cross-section of the side drain shown in Figure 19.1. All drains must have adequate and enable the free flow of the collecting water. Figure 19.1 shows the typical cross-section of the side drain. Side drain 300 millimeters. Standard ballast profile. Side drain 300 millimeters. Line of drain. Side drain lines imperative of the Group A routes, preferably on all other routes except for the routes of the drain with the rocky strata. Adequate opening with the under level of the crossing in order that the water level flow of the side drain. Cutting the adequate opening with it should be provided under the level of the crossing around trolley refuges and other overhead electrical masts. Catch water drain. Catch water drain should be provided whenever the necessary cutting with the side. There should be worked according to the volume of the work of the drain is expected to carry. No surplus ballast. Surplus ballast shoulders of the track retard the drainage that curves the vegetation growth. All extra ballast should be taken out of the track stacked in small heaps beside the track. 9.5.2 Drainage and station yards. When planning of the draining of the station yard, following guidelines should be kept in mind. Open surface drains. Surface drains should be generally have left open when the cleaning of the inspection convenient when designing the yard drains. Velocity range of 0.5 to 1 meter second may be allotted, but the earth drains it's 1 meter to 2 meters second of the other masonry. Saucer shaped drains. Mentioned earlier, longitudinal drains lie between the two tracks that should be saucer shaped with the curved side. However, the drains vertical sides may provide whenever the saucer drains are not practical. Drain top not to be assessed normally. Normally, the drain top should not be above the assessed level of effective drain level of the ballast bed. However, the essential drain would have the higher top of the level to be provided within in order to retain the ballast sweep of the hole. The must also provide the assumed condensed level of the drain, so the designs of the water carries out does not flow with the base level of the weep holes. Outflow with the slope, wherein the proper outflow is available at either end of the yard. With the longitudinal drains provided should be have with the slope the facing direction opposite middle of the yard to ensure they minimize the depth of the drain. Position of the ballast section. The ballast section of the station yard should be the same as the mainline network of the cross longitudinal drains. Every station should have the network of the cross and longitudinal drains whenever whether earthen or masonry, which allows the water to collect during the storm to be carried out at least possible time. The arrangement of the surface drainage of the water column, the carriage of the water point, the water with washing hydrants should be sufficiently maintained. At least these location waters must be adequately trapped, borne, and away from the pipe of the line drain. Open drain section. Figure 19 shows the detailed sketch of an open drain that provided between the two tracks of the railway line. Your open drain tracks is an open drain. You have your concrete sleeper that's still open drain, and your cement concrete 124 smooth concrete 148. 1953 drainage station platform. The following points should be taken into account with the planning of the drainage system of the platform. Sloped away from the track. Normally, L end form should be sloped away from the track of the detailed drainage system of the platform, illustrated in Figure 19.3. Your drainage platform has a drain cement concrete open drain with between the sleepers cement plaster center of the track precaster RCC slab, grading platform, drainage water, CAI pipe, cast assessed level, and lime concrete. Your discharge non-track slide. All drains from the platform shelters T-stalls as well as water taps should be encompassed with the pipes and should be normally discharged with the relief of the content non-track side of the platform. Converted longitudinal drains should be provided within the platform necessary. Discharge not toward the run through the lines that keep the island platforms. All the discharge contents less important side of the track, no towards the run through the lines. 9.6. Subsurface drainage. When normally teeth of the subsurface due the capillary action seepage from the adjacent area of the percolation of the rainwater, the water reaches the subsurface with an immediate effect of the stability of the formation. The situation becomes worse, particularly if the soil has bad variation problems that arise due to the proximity of the water subgrade. The nature of the problem faced with the remedial measure of the same have to discuss in Chapter 9. For a sub-drainage system under the different conditions are briefly summarized here. Provision of the inverted filter. The sub-drainage system consists of the blanket of the non-cohesive grade material which acts as a capillary breakaway, paving the catch water and draining the entrance of the water between the subgrade can be checked with consecutively checked by construction effect of the catch water drains and are duly paved. Provision sand piling. Some drainage systems are provided with an adequate number of sand piles. Diameters about 20 centimeters. They improve the subsurface drainage water pockets of perforated pipes with a diameter of about 30 centimeters provide the appropriate place for the drain of water pockets. Cement grouting. Cements can be used for the grouting of water pockets as either the situation drain water pockets, the puncturing holding. Special case situations of water is trapped in ballast pockets because of the impervious level that lies over the good previous layer of the puncture hole. The impervious layer can help to drain away the water. Chapter summary. Alright, the presence of the water can be reduced stability, the strength of the track, erode the bank of the remaining lifespan of the track considerably increase the providing with the proper drainage system. Whenever the source of the water entering the track, the removal of the track should be quick and effective. In case of the soft soils, subsurface drainage being made necessary to keep the track safe. Chapter 20, modern method of track maintenance, which I wanted to get to.